Welcome to the Databricks Skill Builder series. We're glad you're here.
Hi, I'm Michelle Deng, Specialist Solution Architect at Databricks, focused on data warehousing. In the next 10 to 15 minutes, I'm going to walk you through a journey of Databricks SQL Serverless query based on the blog I co-authored with my teammates, Pamela and Anurag. Okay, so let's get started. Let me share my screen. So here is the blog. The title is Understanding the Journey of a Databricks SQL Serverless Query, Stages, Caching, and Optimization, so which is published on Medium. So this blog was inspired by real conversation with customers. So where we often heard the same questions, especially about caching, SQL query profiling, and what the different query stages actually mean. So our goal is to break down these basics in a simple and easy to follow way. So from understanding cold, warm, and hot SQL state to spotting where a query might be slowing down. So this can help you make better tuning decisions or ensure fair comparisons during a proof of concept. So let's get started. So whether you're trying to speed up dashboards, troubleshoot slow queries, or run a fair proof of concept comparison, understanding what happens behind the scenes like caching data states and query stages helps you avoid guesswork and focus on what actually makes a difference. So as shown in the example journey diagram here, so each query in Databricks SQL Serverless passes through several stages. So from compute provisioning and metadata processing query optimization to query execution and result fetching. Each SQL also has a temperature state due to query caching, typically described as cold, warm, or hot. So Databricks SQL uses several caching mechanisms to improve performance. The disk cache stores data on local SSDs after the first query. So speeding up repeated data reads. The result cache saves the output of completed queries, allowing identical queries to return instantly without re-execution. So the result cache includes both local and remote result caches. So by storing query results in memory or remote storage mediums, the local cache is cleared on cluster stop or restart. But remote result cache is a SQL Serverless specific feature and can persist even after restarts. So query performance depends on data state. In a cold state, so everything runs from scratch and is slowest. In a warm state, this caching improves speed. In a hot state, without caching enables near instant execution. So to test execution performance without caching results, without cached results during benchmarking, you can temporarily disable without cache using this parameter use cached without equal false to disable the without caching. So to really understand how query performs, Databricks provides a built-in utility called the query profile. It breaks down each part of the SQL query journey and shows exactly where time was spent. So on the screen here, you will see example screenshots of the same query run 3 times. So first is a cold query. So second as warm, third time as hot. So this helps us, SQL profile help us connect what we see in query, different query stage, and also what SQL state it is in. So one quick clue is the cache indicator next to finish. If you look at hot query screenshot, there is a cache indicator next to finished status. This indicates this is a hot SQL, which benefits from query without cache. So another helpful metrics is bytes read from cache. You see it's here. So if you see some percentage which is greater than 0%, it means that this cache was used. Reading data from local SSD storage instead of cloud storage. So this is the scenario where we call it warm SQL. So each stage in the profile represents part of the SQL journey. You see this waiting for compute is the time spent starting up resources. So optimizing query and the pruning file is where Databricks knows metadata and builds the query plan. So execution is where the actual processing happens. Result fetching by client is the time it takes to send the results back to the user. So by reviewing this stage, you can see how caching impacted your query and where time is being spent. So it's a great way to identify bottlenecks and figure out where optimization will make the biggest difference. So now let's walk through each stage of the Databricks SQL Serverless query and talk about how you can optimize performance at each step. So compute provisioning. So when a query runs and the SQL Serverless warehouse isn't already active, so there is a short startup time, usually 2 to 6 seconds. But this can introduce delays, especially for the first query or during low traffic periods. So to reduce code start wait time, so you can adjust the auto stop setting of the SQL Serverless to match your workload patterns. So for example, if your team runs query every 10 to 15 minutes during the day, so setting auto stop to 20 minutes keeps the warehouse ready and avoids repeated restarts. But at night, when there are less activities, a shorter auto stop time, like 5 minutes, can help save costs. So you can automate the adjustment of this setting or start up and shut down of the SQL Serverless using the Databricks REST API. So warming things up before peak usage times. So metadata processing and query optimizing query. So this stage shown in the query profile as optimizing query and pruning files. So it's where Databricks prepares a query. It looks up tables, checks permissions, loads metadata, and prunes unnecessary data. So the first run usually takes longer since metadata is fetched fresh. Future runs benefit from caching. So if this stage feels slow, check for too many small files in your data tables. So since this increase log processing time, also, overly complex queries can slow things down. Simplifying them can help improve performance. So the query execution stage is where the query actually runs. So if this part is slow, caching can help. So running key queries in advance helps preload metadata and warm up caches. So later queries run faster. But beyond caching, Databricks has built-in tools to help you speed things up. So a few to know: liquid clustering in Data Lake makes it easier to organize data for better performance without needing to overthink clustering keys. So predictive optimization automatically handles tasks like optimize, vacuum, and analyze, keeping your table statistics up to date. So data modeling strategy like star schema or one big table can help, but depending on your use case. So the key is to choose a model that fits your data and your workload. So the final stage, result fetching by client, is the time it takes for results to reach the user or application. This depends on both the Databricks SQL endpoint and the client connection. So if the connection is slow, or if you are transferring large results, you may see delays. That's where Cloud Fetch comes in. So for results sets larger than 1 megabyte, Databricks leverage Cloud Fetch feature to store the data in cloud storage and lets the client download it in parallel using pre-signed URLs. This reduces the load on Databricks and speed up without delivery. So we walk through the full journey of the Databricks SQL Serverless query. So from compute provisioning, metadata processing, and query optimization to execution and result fetching. Along the way, we explored how caching affects performance and how to identify cold, warm, and hot query states. So understanding where time is spent helps you identify slowdowns and apply the right optimization strategies. With these insights, you can improve performance, ensure consistent benchmarking. Hope you enjoyed watching and found this session helpful. Be sure to check out the full blog, try out the strategies, and let us know how it improves your query experience.